Okay, thanks, Rob. We now have two presentations about route servers, as my American colleagues would call them, but I call them that so they don't get confused with root servers, which we've also been talking about today. So first of all, Andy is going to tell us about the route server bake-off that they did at LANAP.
Yep, thank you very much, and with the help of a lot of other exchanges as well that are listed on the screen. Elisa from AM6, Chris from Switching Data, Mo from Links, Wolfgang from Vix, Robert from Plix, and Sebastian from DKIC. So it was actually a team effort in the beginning of December to find some limits of the root server software that we've been all rolling out over the last 6 months or so, and check that a load of bugs that each other had found had been fixed to a standard that was acceptable by the group. I'm going to try and present a week's worth of research in 10 minutes. And I'll do that by covering 4 areas as quickly as possible. What root servers do, which will be very brief because most people in the room are going to know. What the situation was before the tests, and some general overview of what we found in the tests. So starting out with what they do. Why would you care if you're in the room? If you're at an IXP and want to start peering at root servers, but you don't know the stability of them. If you are looking at building your own root servers inside your own organisations and networks to help you scale, if you want some of the features that have been put into IXP root servers so that you can run multiple networks or whatever on your own root servers, this will be of interest to you. So it's not just for people who are peering. Briefly, what they do: there's a collection of people at an IXP in full mesh. As more and more people start to join the exchange and peer, it gets more necessary to work out how you can scale that more effectively, so you employ magic in the middle, which means that you just have one BGP session and it causes traffic to flow where it always did. Why is that actually a problem? Well, you have to start scaling it as more and more people join, and then more and more people join, and then some of them want to employ filters between each other, which compounds the logic much harder. And then somebody does something wrong and a router catches fire or starts leaking, and the magic turns to doom. So they're the situations that we're trying to avoid. In November 2009, the IXP community, instead of complaining to each other privately in hushed corridors, they decided to start telling root server vendors what was wrong with their software, so that they could fix some of the problems that we were having. But the patches that were put into existing software and the new software that was shown to us, we didn't know how it would scale. We were finding new bugs, and there was no sort of coordinated effort to make sure that the software was suitable and fit for purpose. So we met in 2009. We all sat around laptops for a week in the Links office, and we worked out. We first of all shared an awful lot of knowledge, and we found a lot of bugs. So the test that we did are split into functional tests. Does the software does as it's meant to properly, and performance? Well, how far can we go? So very briefly, we found a number of bugs over the course of last year that we all wanted to test that week. And we were pleased to discover that all of the bugs have been fixed to everyone's satisfaction, particularly that when new ribs were created of software, if you didn't restart them, that caused inconsistent behaviour. Those bugs were all marked as fixed, and were actually fixed when we tested them. Also, issues to do with filtering. We didn't know if the filtering rules in different pieces of root server software, when we wrote similar features, did they actually behave in the same way, so that you could roll out multiple root servers of a different software type and offer a consistent service? And we were pleased to discover that they did, and all the other features that were expected to be working did work. And then we wanted to make sure that if all the different root servers handled prefixes and attributes in exactly the same way. So we built a little lab using olives and dynamics, so that we could actually take the packets that would have been hitting the routers in a TCP dump and actually analyse them to make sure that they were identical. And we announced some prefixes from a router and sniffed the packets after they'd been through the root servers on a Cisco and a Juniper, which had different levels of expectations and different capabilities, to make sure that the behaviour from both an OpenBGP and a Bird root server was completely consistent. And we're pleased to say, again, it was. Again, for ASN32, we made sure that compatibility mode worked, and in the same way with both OpenBGP and Bird. So we announced from a high AS number, a prefix, where compatibility mode was needed, that was done properly on both root servers, and where no compatibility mode was needed, that was done properly on both root servers as well. So we were pleased to summarise at that point a common handling of all attributes across both root server families tested. IPv6, there were an awful lot of IPv6 issues with OpenBGP in versions that we use in root servers last summer. We wanted to test that they work. The issues were that when a session was reset, it would sometimes cause other sessions to reset, not the one that we tried to reset on the command line, or the session would go down and not come back up again. And those bugs were appeared to be fixed when we tested them with OpenBGP in the lab. Problems still remain with MD5 sessions. We saw unpredictable behaviour, yet we couldn't make the unpredictable behaviour happen consistently, so we still don't understand the issues with TCP MD5 on the root server software, but it looks possible that the reasons that we have issues with them are related to the underlying operating system, not the root server software itself. We could be wrong, and that might be worth explaining to me if you know the reason that we see unpredictable behaviour. But you don't have to use TCP MD5, and for example at LUNAT we recommend that people, well, we say we don't support TCP MD5 on the root server so that we don't have the problem with inconsistent behaviour. Then the performance and scalability, we ran an awful lot of tests to test the scalability of the root servers, and there's only really time to produce to summarise general themes, but one particular test that we ran does summarise the general themes very, very well. This is the lab that we built. We had an Ixia that was able to generate BGP sessions that displayed particular behaviour to a number of root servers that we built, and on the root servers we ran software to analyse the performance, the CPU load, the memory use, and the behaviour under load is best. I think the different behaviours were best demonstrated with this particular test that we did, which was 100 simultaneous sessions announcing 500 prefixes flapping at random overnight. And with Quagga we noticed that there are two particular behaviours that are undesirable. First of all, the CPU seems to run away with itself and never at random it was flapping all the time, and sometimes the CPU was pretty idle, but at most of the time the CPU was 100% all the time. And there are these interesting shapes on the memory use graph where it looks like it's been running for about 10,000 seconds, and then the memory starts to just get swallowed up until there's almost none left, and then rather than crashing, the box goes, oh, I think I'm about to crash, and recovers all the memory, but a few hours later it just crashes and runs out of memory. With Bird, memory use and CPU use remain pretty constant, and it exactly follows the CPU utilisation described by Nick in his talk this morning, where the CPU spiked really high at the beginning for the initial convergence, and then it displayed maximum use in line with the amount of flapping that the Ixia was doing. So that was as we expected, but memory use actually stayed constant. It was very interesting and good because that's predictable. An OpenBGPD, a very similar one, again, high CPU use at the beginning, and it was particularly efficient because with 100 sessions and 500 prefixes flapping at random, it only normally peaked at about 40% use, whereas the other peaked much higher. There are two lines on the OpenBGP one because there were two threads that we monitored because it's a multi-threaded piece of software. Again, memory use fairly constant. In terms of capacity, prefixes are only really limited by RAM, so notwithstanding the issues that Nick said this morning, an overall theme that we found was if you need to support lots of prefixes, you just have to put lots of RAM in there, but there are particular limits with pieces of software that mean that you'll hit a ceiling at some point. With OpenBSD, there's a 1 gig limit per thread if you run the 32-bit version, so you can't scale past that without running the 64-bit version and things like that we found. The equipment that we had to test was 32-bit, so we're going to run that test again with 64 over the course of the coming weeks. And the number of sessions, the thing that stood out most of all was that Bird, when we started 1,000 sessions with Bird, With no prefixes, we found that the CPU flatlined at 100%, and the software was unresponsive. So we're going to discuss that with the developers, because it's not really a problem for anybody apart from the very largest exchanges, but that is going to be a problem for those guys. So we're trying to understand why there seems to be this limit. It's nothing to do with operating system limits. We think issues like file descriptors, but allocating more file descriptors doesn't make that problem go away. We don't understand that one yet. But as a quick conclusion, if you talk to people in the room who are operators who use root servers, they'll only tell you about doom, gloom and bugs. Where are they? Well, actually, as of the end of last year, there are actually new, more scalable root server daemons that IXPs can use. The software vendors, the open source software vendors, have been fixing our bugs and paying attention. And if you're an ISP in the room that is tempted to connect to the root server, let me try and use Nick's analogy. If you don't know why you don't want to, but you haven't and you do want to, then you should then you should to use Nick's logic and mine mixed together. Then you probably should start talking to your local friendly IXP operators and talk to them about bringing up a session, because things are different and are more stable now. Any questions? Sorry, it was a bit of a whistle-stop tour, but there's a week worth of stuff. Thank you.